I met Bud kind of in the same timeline that I met Ellen. I was a RISE fellow, and we were at the American Wind Energy Association conference. I walked up to his booth just wanting to know more about the company that he was representing, and to my amazement, we met, and he is the ultimate bearing. Anyone who knows me knows that I am a huge wind nerd, and I think Bud is the equivalent of me in the bearing world. Um, so you know that this statement is very true if I'm telling you that he's the ultimate nerd, and it's amazing. But he taught me so many things about bearings that day that really inspired me to continue pursuing my mechanical engineering career. And Bud and I have met up at conferences recently, stayed connected on LinkedIn, and he really is the true definition of an all-knowledgeable bearing engineer, and an even bigger inspiration to any mechanical students looking for insight into a true engineering career. It's my pleasure to introduce you to Bud Frabell.
Oh, thank you, Jessica. Yes, I am the atypical bearing geek, as my boss calls me. So I'm not going to go as much into my background and all this stuff. Grew up in a small town, joined the Army, went to college, yada, yada, yada. Let's get on to the fun stuff. Education is so critical, guys. Really, getting that engineering degree is such a door opener. The thing, after you have your degree, every company out there is going to have to teach you a lot more, and that's what I've learned. As you go into a company, you do all this extra college. So I got sent to Penn State University and did some advanced training on bearings. It was very, very design heavy, but very critical. So just keep your foot in there, keep working, get that degree. It's truly worth it. So we're just going to get onto some guts here. I like this stuff better. So in the wind world, for me, some of the major projects that I've worked on in my past when I worked for Koyo Bearing is one of the main ones was switching a deep groove ball bearing from standard 50-100 bearing steel to a ceramic hybrid style. And my second one was qualifying a main shaft bearing, a 240/600 spherical bearing for GE. Digging a little deeper with the ball bearing, it was kind of an interesting thing is when wind turbines first started, there wasn't a ton of them. Not a lot of people were paying attention. But as the number of turbines grew and the sizes grew, all of a sudden problems started to appear. Original equipment manufacturers needed to find a way to resolve these issues. Their objective was, of course, to get past their warranty period. In these turbines, we're having issues with the bearings from self-induced eddy currents, faulty wiring, so on and so forth, causing your bearings to not last as long as they were supposed to. So I was assigned with GE, at the time it was Enron, to study the ceramic ball versus the ceramic coatings and standard bearings. Now, what's very interesting to me is today, all three versions are up in the air. Many times you'll find the best engineering solution, but it's not cost effective. So it gets kind of side railed and moved on to something different. Next one here was kind of a unique one for me is the 240/600 spherical roller bearing for the main shaft. This one was kind of neat. I got to do all the life testing and all the design project on this one. And once we had all that approved, I took a trip with GE over to Japan with their quality department and walked through the entire process. They wanted to be able to track a bearing component back to original material. So it's kind of interesting working a bearing backwards to the raw steel. So next slide. I know a lot of folks in the engineering world are motorheads, and their dream is to work for an automotive company. That's all good for those folks, I guess, but not for me. I was so happy to work for the industrial side. It allowed me to work with every type of bearing under the sun, and I got to work on so many cool applications and been all over the place. I worked on things like spinning bikes. I worked in steel mills. This one right here is pretty cool. I worked on multiple axis robot arms used in special environments like vacuums, to where I was dealing with really fancy materials like ceramics, special greases to keep away degassing and stuff like that, and of course wind turbines. As time moved on, I decided to move away from working for the OE, and I decided to work for an aftermarket company. Midpoint Bearing that I work for today, they specialize in electric motors. And as time had gone on, electric motors is almost the exact same thing design-wise as a generator. So it was a very easy transition for us to move into doing business in the wind turbines. Now, I actually have two roles at Midpoint. I do sales and I do engineering. But we'll skip the sales and just look at the engineering because that's probably my favorite part of my job. So the about failure analysis from my OE experience and working with manufacturers in the field, I found that many bearing manufacturers had the stance of finding the problem to be not my fault. That's fine, but it's not very helpful when you're searching for a root cause. On the screen, you'll see a failure of a 240/700, if memory serves. That's a 700 millimeter bore, which is about 27 inches. These are difficult to move around, so when you have one of these failures, a lot of times you go to the bearing, as I did in this particular one. On the bottom side there with the red arrow, you see that we started to notice a few issues. We saw some sliding and we saw some thrust loading issues. To me, what's kind of interesting is, in my world, we're always dealing with what I call an aftermarket upgrade. On the OE side, once you pass warranty, everything's good, nothing bad about the OEs, but most wind turbines, they want them to last for 20 plus years. So we had to find a way to address these issues, and we call them aftermarket upgrades. So we work with the bearing manufacturers directly and come up with these upgrades. In these particular issues, we identified the skidding, and to resolve that, we put in this Trundor coating on the rollers to avoid skidding, and the axial load, we actually adjusted the contact angle on this side of the roller bearing to allow it to handle more thrust load. We have multiples of these up in the air right now, and they seem to be doing really well. So it's kind of neat to see success happen. Other type issues that I run into is this was your pitch bearing motors. The customer thought they were having current issues, so they sent the bearings to me. I tore them apart and inspected them, and I found out that what they were having is actually a problem called radial preloading. So after bouncing around what we can do to fix this, came up with a few different ideas, and we actually went with using the high temperature steel and Vicon seals. Okay, 1 minute left, so go faster. I'm almost there, Jessica. Another one that we had is a lot of times we'll run into really big ones. This is it's actually a 240/800, so a very large bearing. Customer thought they saw damage during routine maintenance. So they took this main shaft down along with the bearings. I flew down to Texas along with my Scheffler field service guys, disassembled, which destroys the bearing, and we found absolutely no damage. So a lot of times we get stuck in situations that aren't easy to explain to the end user that you just threw away a $40,000 bearing, plus who knows how much it costs per crane and all that kind of stuff. So I love bearings. Jessica said it, I am the true bearing geek, and I'll be here for you to answer any questions you may have. All right, thank you.
Awesome. Thank you, Bob. That was great. I'm so glad you went into some of the technical aspects of your job and not just the standard, this is my education that someone can just read. So thank you for that. Moving forward,
No problem.